Hello and welcome to the reciprocal system of physics, a new way to look at an old universe, with physicists Bruce Perret and Gopi Vijaya. This is the first in the Center for Anthroposophical Endeavors Realignment of Science webinars. I'm Ann Nicholson, the Center's Program Director, and I'll be your host. About the presenters. Bruce Perret, PhD, has a comprehensive background in computer science and electrical engineering. He's a full-time researcher of the reciprocal system, focusing on the foundations of electrical theory. Gopi Vijaya, PhD, works with experimental and theoretical semiconductor physics. He's engaged in postdoctoral research of the reciprocal system as a way to bring Goethean thought into modern physics. If you had a chance to read Gopi's paper, Preparing for the Reciprocal System, he points out that the sciences are suffering from a gap between assumption-based and model-based approaches. This is where the reciprocal system can bridge that gap. A quick note about our format. The presentation will be divided into short sections with breaks in between for questions and answers. You can submit questions at any time by clicking the Q&A icon on your screen. And during the breaks, we'll answer them live. Okay, let's get started.
All right. Hello, everyone. Thanks for joining us. I'm going to start sharing the presentation. Hopefully, everyone can see it.
I'm not doing it. Now go.
The other one. Yep.
There it is. I'm just going to slide out of the way.
Yep.
You can talk.
All right. So, reciprocal system of physics, new way to look at an old universe. Now, what are we looking at when we are trying to look at a different way at physics? So the first thing is to talk about the reciprocal system itself. This method of doing physics was actually inaugurated by Dewey Larson back in the 50s with his first book, The Structure of the Physical Universe. And I have the website link provided below for those who are interested. But the most important idea that Dewey Larson brought to physics was the concept of a universe based on the natural consequences of a ratio of space to time called motion. In other words, he was looking at the entirety of the physical universe only on the basis of this one single unified concept. And that is the big change that we'll be describing further on in this presentation. Now, obviously, in looking at a theory of this magnitude, what Larson created was something that can be called the first draft. It's not something set in stone, it's continuously developing. And as of today, we have a further iteration, you could say, a re-evaluation of the reciprocal system of theory, the next generation of Larson's research using 21st century concepts. And this was done by Professor K.V.K. Nehru from India and Bruce Perret, who's with us today. And it originally began in an attempt to explain the properties of black body radiation. The important addition, the 2 in RS2, if you will, is the fact that angular, or what in ancient Chinese philosophy is called yin, concepts were also introduced in addition to Larson's more linear kind of yang system. Now, with this as the fundamental introduction to the reciprocal system, we have to understand how we look at physics in general. And that is this particular conventional theory way, which we all kind of imbibe over our educational process. The first thing we kind of assume is we always assume that content and container are different. Now, this is the view of objects in the universe being like actors who play out on a stage, a background of space-time. So whenever we imagine something moving here and there, we always think of this particular object moving in a background of space-time. So this distinction is something we kind of take in without really examining it. The background is separate from the objects. The observer is separate from both the objects and the actors. So these are several levels of separation introduced. And when something does happen, you're trying to describe things in this particular way of looking at it, that an actor did not do, right? And something unexpected happens, then immediately an excuse gets created. And this is the idea of force fields. We'll come back to this in a little bit, but in the first place, we try to understand what happens when this stage kind of idea and the separate background, separate object, separate observer idea is not assumed, and we start from a different point of view. Let me show you a quick clip in order to illustrate this further.
The force-carrying particles exchanged between matter particles are said to be virtual particles because, unlike real particles, they cannot be directly detected by a particle detector. The people on this planet will swallow anything.
So, in other words, we have swallowed many things which you're not supposed to be swallowing, and actually examine it in a scientific way. What are these things that we have swallowed? So, looking at that, what we have swallowed is, for instance, the idea of action at a distance. Whenever we are having phenomena that seem to fit more with the action at a distance kind of idea, we tend to bend the stage using the idea of electric and magnetic gravitational fields. So these are the things that, for instance, do not fit. The stage does not stay put behind the actors, whereas the stage actually starts participating in the phenomenon. And similar problem is seen as faster than light motion. For instance, when phenomena happen which don't very neatly fit within the Einsteinian view, where everything that happens is less than the speed of light, then a lot of anomalies are seen. And in order to fit these anomalies in, for every single anomaly, a new concept is introduced ad hoc. For instance, you have black holes, you have white holes, you have all the interesting properties of millisecond pulsars. Again, you're trying to resort to bending the stage to make it work. But is there a way where you do not try to bend the stage? Because what we don't see still affects us. The background is no longer something that sits neatly behind us. So this is the point at which we kind of stop this preliminary intro and really start diving into what it means to have a universe of motion. So let me pause for a couple of seconds to see if there are any questions at this point, and then I'll continue on from here.
Okay, there are no questions from the audience at this point, Gopi.
Yeah.
It's something that this theory is challenging a lot of the things that those of us who have what we thought was a modern scientific conception, we're really going to have to take a new look at things.
Exactly. Yeah. The idea is not that we necessarily have to, build up a new theory again in an ad hoc manner. The perceptions and the facts remain the same, but the interpretation becomes much more coherent. That's kind of the aim of this whole system.
Gopi, we had a question come in. What does this do for the concept of rest mass?
Rest mass.
Rest mass is, well, for that, you have to understand that the very idea of mass is extremely tied to the idea of an object in the stage. So when you're looking at mass in the terms of reciprocal system, it turns out to be something else. So I will try to come back to that once we have gone through a good part of the presentation. Keep in mind and try to come back to it.
I'll remind you.
Mm-hmm. All right. Anything else?
No, let's move on.
All righty. So the reciprocal system. Now, the unique thing here is everything is a ratio of space to time, no exceptions. That means the actors, which are the objects, are a ratio of space to time. This stage or the environment is a ratio of space to time, and the observer, that's you, are also a ratio of space to time. That's one concept applicable everywhere. Now, the reason for doing this is described a little bit more in my paper on preparing for the reciprocal system, where when you look at how measurement is done in modern physics, no matter what the physical quantity involved is, in each case, whether you're measuring mass or you're measuring charge or you're measuring anything, any other intensity, energy, or things like that, you ultimately come back to measuring some particular quantity of space or a frequency, a quantity of time. So when the measurement process intrinsically involves these two quantities, what happens if we start with them while looking at our theory? So rather than trying to fit everything back into spatial and temporal terms, what if we start with it? So that's the idea of the reciprocal system. And now, since everything is a ratio of space to time, the ratio of space to time is what we typically call motion. So the ratio of motion, so basically when you're looking at space to time as a ratio, the motion, there are only two options, the two differentiations possible. One is you can throw it, another you can spin it. There's no other choice. For instance, whenever you're thinking of, say, throwing a baseball, the movement is something that happens in a straight line, traditionally and philosophically associated with yang, hot, masculine, and it is what is traditionally used to define location as well. You say, you see a ball move across and you say, that's where it is. So the very movement is what helps create its position in space. That's the basis for us measuring it. On the other hand, angular motion is different because in this case, the location does not change. The rotation occurs in place. It's more on the yin and the cool and the feminine side. And not only does it stay in place, it also defines structure. In other words, both movement and what we would call an object or a structure, they are something that is two sides of the nature of motion itself. And when you pursue that concept further, it comes to the idea that you can have motion without something moving. Absolutely preposterous idea to start with. At least that's the first impression. How can you have motion without anything moving? That's the number one question that trips up almost all students of the reciprocal system. And the reason is we are still thinking as an actor on a stage. Because when you actually look at it, the motion is basically how we are measuring change. Something is changing. Now, when you have, say, the wind around us, we don't normally perceive it, right? It just blows past us. It's a linear movement. We barely detect it. But when it really ramps up and starts circulating in place, then you have a tornado. So when you have a tornado, there is no question that it is something. Everybody agrees it's a pretty powerful thing. But what has happened is motion that used to be linear has kind of focused itself in rotational form. And so both things are still motion. So the reciprocal system is based on identifying these differentiations of motion. You can almost call it a kind of topography, a kind of landscape of motion. And therefore, it is based on an abstract change in multiple dimensions, not as things moving. Okay, let me pause once again over here to see if there are any questions so far.
Well, can you talk about what you mean by the word abstract? Because I think you mean something very specific here, not what maybe is commonly the common definition of that term.
Yeah, so when you're talking about abstract, well, abstraction means that you're going a conceptual level higher than what you normally deal with. For instance, when you just say a blanket rule, motion, right? It covers everything, but then you have to abstract certain features out of it. When you say just a landscape is a landscape, but then you start differentiating things. You say there's a hill, there's a valley, there's other features, height changes and things like that. These are abstractions that you get from the landscape. And in a similar fashion, what is happening here is the same way that you'd have a topography, you have a three-dimensional universe, in the same way you have here a topography, but with motion, not static objects, but actually movements and motions differentiating themselves into multiple dimensions. That's kind of the meaning of abstraction over here.
So you're talking about map making here.
Yeah.
Yeah.
Different kind of map making with everything being in motion. So that takes a little getting used to, because we have had so many centuries programming to think in terms of static objects that it's kind of hard to think of motion being the first thing.
Okay, we've got two more questions here. One is about scale in relation to rotation and linear motion.
What is the scale?
Yes, can you talk about scale here? Measurement and scale in relation to rotation and linear motion.
Well, think about it this way, where you have predominantly rotational motion, you end up in what is called the quantum scale. And that is the layer where all of us are very familiar with the ideas of atoms and systems and basically the stuff of our physical universe, right? But when you're actually looking at it more carefully, even in the most fundamental equations of quantum mechanics, you're actually still talking about rotations. So you even have spins, you have so many different ideas where people are trying to get the topography of rotational motion. So a typical scale for rotational motion is that of atoms. And I'll come back to this later again, that that's not the only one. You also have...
You mentioned natural units.
Yeah. You also have the idea of rotations coming when you're looking at astronomy. So I'll come to the meaning of that towards the end of the presentation. But the thing is here, you have an idea called natural units. So the scales are determined by what you choose as the natural unit for your physical system. And I will describe what is the logical choice based on the phenomena for this natural unit further on. It will turn out to be related to the light speed, which is the scale for many things.
Okay, excellent. We've got one more question.
Yeah.
This one is about warmth or heat, and that's considered to be, you know, the primal quality of matter in some systems. So is this really about identifying that primal phenomenon?
It is identifying the primal phenomenon, but because we are starting with a different sense, we are starting with the sense of the eye, the sense of vision. So the sense of warmth, if we would start there, we would develop another coherent kind of way of looking at things. But in this way of looking at it, you're starting with something you can very clearly observe, and then the explanation of warmth also comes out through understanding motion itself. So the two things are complementary, but for the sake of the bridge needed with conventional physics, we're starting with light and movement.
Okay, excellent. Let's move on, and I know you're going to answer more of our questions as we get deeper into the presentation.
Yep, I hope so. All right, so moving forward, we looked at the idea of the state getting bent, and here what we are having is, say, two poles of a magnet, and you sprinkle iron filings, and the iron filings somehow seem to arrange themselves in a particular pattern. What is moving these iron filings? Magic? We all know as kids, we were fascinated with magnets. And the thing is, there is no specific object between the poles which is creating this system. There's no tiny little billiard balls pushing all the iron filings in the specific way, but the entirety of it moves in a specific way. So in other words, the field effects, which we perceive as pushes and pulls, are just the expression of outward and inward motion. So when you see that something is affecting another thing, that's traditionally how we put the sentence, this effect is also a consequence of motion. How do you know something is there? Because when you're trying to push at it, it pushes back. So there's this interaction of pushes that is the basis for us to say that something actually exists. So all of it, the so-called actors, also turn out to be just modifications of motion, or they're just change. No actors between these poles, just change. So motion can, in this sense, be viewed as pressure. Just like I was telling you, as a push and a pull, everything in the universe can be viewed as a pressurized system. No leaks, no change. Motion is a constant speed. What the universe seeks, a steady state. So in other words, the steady state is not stasis. The steady state is dynamis, it's movement. And when the movement kind of gets accelerated in a way, then you have over-pressurization. And when that kind of goes the other way, you have a suction or a leakage. So the leaks create change and seek to balance themselves by finding an opposite change. So the over-pressurization and the leaking, the push and the pull, the positive and the negative, north and the south, so many other concepts that are used in physics, oxidation states, valence, all of these things are simply showing us how this fundamental idea of polarity or reciprocity is expressed in the physical universe. So carrying forward this idea of push and pull, the steady state part, which I didn't emphasize earlier, that steady state is what we are looking at here. Motion is defined as speed, the multiplicative inverse of space to time ratio. The minimum amount of motion is 1, unity. Now, here is where a conceptual shift is occurring. When you're looking at a universe which is stasis or static, you tend to normally start with 0 for everything. You have an origin in the Cartesian reference system. You have a vacuum, say, for instance, when you're looking at a pressure system. Everything is dealing with 0 to start with. Temperature, absolute 0, so on and so forth. But when you're looking at dynamism or movement as the fundamental basis, then the minimum amount has to be 1. There has to be movement for you to do anything with it. And the universe must contain the minimum motion, this unit speed, as an outward push, as a general progression. So you can have the average state as a general progression, and the balances are the progression, things overreaching the progression and things kind of reeling back from the progression. So the datum or the basis line, so to speak, for the reciprocal system is this progression of the natural reference system. And it is identified with the speed of light. So what happens? Where do we see this? For instance, pull-push, the fundamental yin-yang or polarity of space and time. If the minimum quantity of motion, the outward push, is always present, it should be observable somewhere. In fact, it actually is. In the two images, the one on the left, you see the typical motion, which we are all very familiar with, gravity. You drop something, it falls to the ground. Pretty simple. And it points towards the center of the earth. However, in the beginning of the 20th century, a completely unprecedented motion was discovered. What was that? The fact that all the galaxies are going away from the Earth, almost all of them. And this was completely surprising and puzzling to several scientists because they could not figure out how all of them could be moving away. And this ignored fact, it was ignored for 4 centuries, actually, ever since the time Newton introduced the ideas of gravity. This particular ignored fact turns out to be the opposite polarity, which is required to be present when you're starting with the yin-yang system or a balanced system. So what you're attempting to do is to make up for things which tend to get missed when you only see one side of the coin. And there are other things too. Conventional science typically is pull only, all right? So it has several problems explaining things when push comes into play. For instance, I already spoke about galactic recession. Another very common phenomenon that we don't really know the true reason for in conventional science is thermal expansion. When you heat something on the stove, why does it expand? Why does a metal expand almost photographically when you heat it up? Believe it or not, conventional science has absolutely no reason given for that. When they're talking about all the jiggling molecules and how things are shifted from the equilibrium position, when you look at it very carefully, you realize nothing can actually move away from its equilibrium position. You need something else coming in. You need a push, an outward push. And that's what thermal expansion is. Interatomic repulsion. If gravity was the only force acting, you should have all of the universe getting together and clumping into an infinitely dense spot. That does not happen. When you push on a hard object, it resists. What causes its repulsion? What causes interatomic repulsion? This, again, has no answer, even with the most advanced quantum mechanics. Another thing which happens is extrapolation failures. So extrapolation is very simply saying that, okay, if something has increased while I increase another parameter, then it will continue to increase while I keep increasing the other parameter. Say a kid is growing and he's growing at a certain rate. If he grows 5 centimeters in 1 year, you would extrapolate and say he's going to grow another 5 centimeters in the next year. But as you can see, such failures happen because the kid doesn't continue to keep growing to several feet tall. It stops. And this stopping and then even losing height, which happens in old age, this kind of principle is what it introduced in the reciprocal system. Extrapolation doesn't continue indefinitely. Everything goes to a certain point, hits a limit, and goes in the other direction. So all of these are features of the conventional science which are not explained and which tend to get explained when you take both sides of the picture, when you stop missing half the picture. So this is where we have to start balancing, rebalancing our physics and try to include the properties which we have almost by default left to the side. So restoring the balance. On the left side, I have the things which we tend to know quite well. We know that gravity acts inward, like toward the center of the Earth. We know that similar charges repel. And we also know that similar magnetic poles repel. Right? These things don't traditionally. Same charge repelling, same poles repelling.
Which is similar.
Yeah, similar. So now, when you have outward recession, that's a puzzle. And something else which is a puzzle is similar charges attracting. Now, you might not have typically heard of this, but this is used pretty heavily when trying to understand superconductivity, where electrons are actually paired up. Things which normally should fly apart are put together. And the same thing in the so-called atomic nucleus. Even there, you have several charges put together and nobody explaining to you why they are putting together when traditionally they should be flying apart. So it always seems to explain one part of the system. The most astonishing thing to see visibly is the stuff with magnetic poles. On the left side, I have the image of north poles repelling each other, as it happens with a typical magnet. But on the right side, you have the two north poles of a sunspot clumping together. So rather than repelling, they're clumping. So completely unprecedented. All the stuff on the right is something that takes theorists a lot of effort to fit within their system because they don't start with a balanced system. As you continue balancing the system, there are other things. Somebody was asking earlier about heat and light. So when you're looking at light, outward radiation, when you have a candle and you see very cleanly that it is very bright as you close to it, and as you go away, the light intensity decreases. This is the typical property of outward radiation. But there is another thing that's happening in our physical universe called inward radiation. It is also called cosmic microwave background radiation. Now, in the middle of the last century, people found out that from all directions surrounding the Earth, there is radiation coming inwards to us. Radiation that is so uniform that when you actually try to calculate its temperature, it goes up to the 4th decimal place without any variation. Absolutely uniform inward radiation. That threw all of them into a big quandary because they could not explain inward radiation. So they had to come up with other ideas like Big Bang, which has basically exploded a long time back and somehow you're seeing the residue. So that to fit a particular hole, the idea of the Big Bang had to be introduced. But if you look at it this way, it's simply the polar opposite of outward radiation. And similarly, the thermal gradient, this is an astonishing thing once again with the sun. Thermal gradient, when you go closer to a candle, the greater the chances of you burning your hand. As simple as that, because it's hottest near the candle and cooler as you go away. But when you look at the sun, the surface of the sun is actually cooler than the surrounding corona, which you tend to see during eclipses. So in this case, the heat gradient is completely reversed. It's hotter away from it and cooler at the surface. This astonishing reversal is once again something that is very difficult to explain in terms of conventional physics. This whole method of looking at physics in a balanced way was actually inaugurated back in the early 1800s by Johann Wolfgang von Goethe with his ideas on color polarity. He saw a similar balanced system with respect to the prismatic spectrum. He did not look only at the left side of the slide, for instance, where this is a very common image that is spread all over the scientific books, where you have a white beam of light coming in through the prism and splitting into colors, and you have the typical rainbow spectrum that you see on the left. On the right, however, Goethe put the inverted spectrum, where a dark beam is passing through a well-lit white background, and that also gives some colors. That gives you the CMY, the printer colors, cyan, magenta, and yellow. Now, funnily enough, physics has tried a lot to fit this particular magenta color within our system and failed at it. Because what is happening is something that creates certain conditions for green to appear. If you invert it physically, you should get magenta. But our theory is only made for the green. Our theory is not made for the magenta. So the usual explanation given is magenta is just made up by your brain, whereas green is actually observed. So these kind of asymmetries start getting introduced into the whole understanding of the system. So when you actually take this into account and take polarity, not only with color, but with all other phenomena, then you start getting a system which is balanced intrinsically. And that's what we are calling the reciprocal system. I'd like to pause once more over here and open the space for a few questions.
Well, we have one question that came in about the phenomenon of scale as a primary. Are there three primaries, linear, angular, and scale?
We'll be talking about scale in a minute.
Yeah, we will be
we're
speaking
going
about
to
scale in a minute. If the person with the scale question could hold for a second.
Okay.
Another thing you want to mention here is green has a frequency.
Green has a frequency, yeah.
Try and Google a frequency for magenta.
Yes, that's a good exercise. If you try to go and Google the frequency for magenta, you will see all the evasions that are possible by the human mind put in front of you.
But because of the system here, magenta has to have exactly the same frequency as green, except that it's the inverse polarity.
Yeah. So in a way, you
It's
have
shifted by 180 degrees.
Yeah. You can have like positive and negative frequencies. The ideas like that introduced here.
So that expands it from simply a scale really to a circle, right?
Yeah.
We talked about that during our run through, that Goethe's color theory is really, he portrays it in a circle.
Exactly. So the difference between the traditional way of looking at it, which is linear, and Goethe's way of looking at it, which is a circle, is the circle meets a line only at one particular spot. So you have many different ways of orienting the circle. So there are, in fact, as many physical theories as there are points on a circle, which is infinite. So the idea of making a linear scale means you also tend to start from zero and go on towards infinity. But when you're starting with a circle, you're having one single unit. There's an inside to the circle, and then there's an outside to the circle. So the way in which Goethe approached his color theory was intrinsically the same datum that the reciprocal system uses. It's unit datum, not zero. So that's an additional point there.
Well, we also talked about the Big Bang here during this last segment, and really the RST calls that into question, doesn't it, Gopi?
Yes, it does. Because what is happening is the Big Bang, well, think about it. A bang is an explosion. It's once again a young phenomenon. So they're trying to express something that is actually yin by using terms which are actually young, which doesn't fit really. So the only way to escape it is to put that bang far back in time. So it's so far back in time that you don't see it anymore, you don't experience it anymore. And then you can kind of do hand waving and call that, your incoming radiation. So what you're actually seeing is the lack of inversion, the lack of willingness to actually invert the phenomena, even though the observations are calling for it.
So does RST give us any indications about the beginning of the universe, or about what to expect if there's going to be a heat death or a cold death at the end of the universe?
In terms of the reciprocal system, we have a cyclic universe. So there is as much heat as there is cold, and the two mutually recirculate into one another. And you must also think about another idea of time, which we have not touched on in this presentation. Hopefully we'll do it at another time. When you have the idea of time beginning, then you're reaching a completely different level of concepts. Over here, we are not looking at things in that way. We are just looking purely at the physical happenings around us and seeing, okay, everything appears to be different forms of motion. And motion has two aspects, space and time. We are not divorcing time and space as two separate things to be treated differently. So questions of beginning in time, beginning in space is not the current concern. The idea is to find out how are these things balancing each other.
It is considered a steady state theory.
Yeah, it is considered a steady state theory.
Okay, excellent. Well, let's move on, and you're going to get into scale with this next section.
All righty. Before the scale, first of all, we have to try to give a kind of understanding of what this new datum is. What is the rationale behind choosing light as a new datum? Now, there are two fundamental processes that occur in the observable universe. On the one side, you have speeds. Now, speeds are very, observable in a way. And energy is something that seems far more intrinsic. When you keep increasing the speed, that also is tantamount to an increase in energy. Now, here's an interesting observation that was seen, that a lot of the particles that they observed coming in the upper parts of the atmosphere, they turned out to be having so much energy, so much high energy, that there was no way of trying to find out how on earth these things sped up so much. The high energy particles were coming in very close to the speed of light. And what is observed is that this high energy is something that forms a polarity to the low energy or the low speed side of the physical universe. And when you start touching this kind of boundary of the speed of light, then things start changing. And the way the things change was not totally understood, for example, by Einstein, who kind of reacted by once again warping the stage behind. He did not understand that the concepts that they were being used below the speed of light have to be reversed or inverted when you're going past the speed of light. So this is the main reason why none of us ever heard of speed of light as being in the center of a physical theory. It's always kept at the far end of it. And what I've shown over here in the diagram is when you start with 1, there are 2 ways you can go. The ratio, which is the motion, can go upwards in terms of 2:1, 3:1, n:1 on towards infinity, or downwards, 1/2, 1/3, 1/4 on towards 0. And now 0 and infinity both become kind of limits which are never really reached. And this is true. Almost all physical phenomena, when you say it is 0 size, a point is 0 size, that's not really true, because all physical things have a specific finite magnitude. And similarly, actual infinity is never observed. Infinity is the direction. So between this extreme of 0 and the extreme of infinity, the 1 stands in the middle, balancing the whole system. And unit speed is what we call this datum. And the unit speed equals light speed gives us a physical kind of link point to the whole system. And so you can actually stop talking about just numbers like 1, 2, and 3. You can say 1 is the speed of light. And all processes, therefore, have a limit. Just because the entirety of the physical universe is made of these two reciprocal sides, whenever you're crossing the unit boundary of any process, the whole thing inverts and the reciprocal process starts acting. So you have one side, the other side, and the balancing speed in the middle as the basis of the reciprocal system. So moving on to the idea of scale. The interesting thing in reciprocal system is, since you're looking at, say, push and pulls and things like that, what happens within the atomic or the microcosmic system is very similar to what happens in the astronomical or the macrocosmic system. For instance, in the astronomical sense, you have globular clusters where a lot of stars are, kind of present in a globe, and they're kind of equitably distributed within the volume of the globular cluster. What is happening there is where the pushes and pulls between the stars are balancing out enough to create such a structure. The very same thing is also happening at the atomic scale when you get a whole array of atomic systems. In this array of atomic lattice, what is usually called, a similar push and pull are balancing each other out. So scalar over here means no matter which scale you're talking about, the fundamental physical processes remain the same. So the concept is scale invariance. And motion, which has this property of invariance with scale, is what we are calling scalar motion. Even if you change the scale, the motion's qualities remain the same. So this is a very powerful idea because it kind of provides the antidote to modern physics, which has things which are very different for different scales. For the very small, you have quantum mechanics. For the very large, you have, say, cosmology and general relativity. For the things in the middle, you have a whole hodgepodge of different things coming together. When you're having a physical theory which is scale invariant, that means the theory has the capacity to penetrate very different subjects with equal ease. And that is what we call a coherent system. The reciprocal system, that's why we call it a system and not just reciprocal theory, for instance. Because everything that is happening in various subjects, which I kind of go through, is all very naturally tied together. Subatomic particles. Within the first book by Dewey Larson called Nothing But Motion, he addresses several things which happen with subatomic particles. He actually calculates from first principles the charge of the electron, the mass of the electron, what kind of fundamental particles can there be from theory, straight from theory. So, and when you're looking at nuclei, what are called the atomic nuclei, radioactivity was also examined with the reciprocal system, showing how the radioactive decay and the nuclear radioactive decay products, how they evolve, what kinds are possible, what is not possible, all of which, according to traditional science, they're mostly empirical, but he was able to calculate that. One of the most astonishing calculations that came out of the RS is calculations of interatomic distances. For thousands of compounds in Basic Properties of Matter, which is another book, Larson calculated, just based on the balancing of the pushes and the pulls, what the interatomic distances should be. And this enormous feat has not been paralleled even with supercomputers and all the fancy stuff of modern science. Chemical bonding. You don't have hundreds of different types of bonding. You have one simple force equilibrium being formed. And that explains all the different kinds of bond which is there. Chemical, ionic, covalent, hydrogen bonding, coordinate bonding, what have you. Electromagnetism, heat, liquid state. These are all more not so microscopic, more on a human scale. These phenomena also have a very clear explanation. For instance, why is the electric field so much stronger than a magnetic field? And why is the magnetic field so much stronger than a gravitational field? Questions like this. Why does the electronic specific heat, for instance, not take part in the specific heat calculations? What's the reason for that? What is the actual reason for a state change from solid to liquid and liquid to gas? Our usual way of understanding states is we kind of take the idea of solid billiard balls kind of all mashed together, and we say, okay, if they're all really mashed really hard together, then you have the solid state. If they're kind of loose, then you have the liquid state. If they're all dispersed, then you have the gaseous state. So you always have this idea of solid balls infecting all our physical understanding. But Larson goes through the development of the different states of matter. How, as I was telling you, everything has its limit. In a similar way, the liquid state has its limit, and then it becomes the gaseous state. So based on this idea, Larson actually calculated boiling and melting points of so many different compounds from theory. Once again, an astonishing achievement.
It's quantized. What you do as discrete units.
Yeah.
That's what your limits are. There's no rolling system.
Correct. So when you're incorporating this idea of the limit, that means everything becomes naturally quantized. So you don't have to kind of impose a quantum mechanics since it is naturally quantized. And the limit comes inbuilt within the theory. That is one half of it. And as you go more towards light speed and high energy, then you move towards astronomy and high energy physics. High energy physics, what are the different magnitudes? What are the different decays, particle decays that occur in high energy physics? Once again, derived by Larson in Nothing But Motion. Stellar evolution, our very understanding of stellar evolution, because we are looking at only one side of the coin, we got it backwards. Stars don't evolve from blue to red, they actually evolve from red to blue. So Larson set the evolution right, and that enabled him to explain a whole host of astronomical phenomena. Binary stars, the peculiar nature of binary stars, which is kind of a living manifestation of the reciprocity. You have a very big star, very dull red color, and you have a very tiny, compact, highly dense star. And how do these things form? Come straight out of the system. Supernovae, extremely high energy phenomena, supernova, quasars, pulsars. Why does a globular cluster stay in that particular shape when, according to traditional system, everything should simply collapse in a big chunk? All of this are explained, and going much larger in scale, galactic structures. How do galaxies interact? What happens when they interpenetrate each other? What is the nature of galactic matter? Quasars and pulsars is very important because Larson actually predicted the presence of quasars way before they were discovered. If his theory was much more well known and if people have understood it, this would have been a Nobel-worthy achievement in itself, leaving aside all the other things. So the reciprocal system also helps you just from natural consequences, developing the natural consequences, you can actually predict what people will find in certain conditions in the universe. And the centering thing in all of this is the light speed. This is where things change. And this is kind of what holds the fort. It's the boundary, as kind of membrane between these two aspects of our physical universe. So in other words, you can almost think of the entirety of the reciprocal system as a description of how light is expressed in different gradations as the physical processes that we see around us. Now, this idea that light is the fundamental kind of constituent of our universe is not as outrageous as it might first sound, because it also came in a quote by Rudolf Steiner, where he looked at matter in the light of knowledge. So let me read out this particular paragraph to you to emphasize the importance of it. There is a fundamental essence of our material earth existence, out of which all matter only comes into being by a condensing process. And to the question, what is the fundamental substance of our earth existence? Spiritual science gives the answer. Every substance upon the earth is condensed light. There is nothing in material existence in any form whatever which is anything but condensed light. Light cannot be traced back to anything else in our material existence. Wherever you reach out and touch a substance, there you have condensed, compressed light. All matter is, in its essence, light. So this is the fundamental message that we are trying to get across, that this is not simply an idea thrown in the middle of nowhere. It has actual physical backing, lot of calculations, and the condensation is what we were earlier describing as the different speeds, the fractions and the multiples and so on. All of them are simply different condensations of this light. So this reciprocal system of physics starts and ends with light. And with that, I'd like to come to the end of my presentation and open the door for questions. Thank you.
Okay, good. Well, it sounds like, just to get us started, Gopi, that you and Bruce are saying that Larson has the theory of everything.
Yes.
Yes. And it must also be specified that the sense organ that we are using, the sense of sight and the sense of touch, Larson put these two together in a beautiful way in his two fundamental postulates and used that to develop the entire theory. And that's why earlier in the presentation, we were trying to look at pushes and pulls and all of that. So it's sense of touch and then light for the sense of sight. The two together, you get the reciprocal system.
Well, there's something that you said in your paper, Preparing for the System, where you talked about this theory bringing inductive and deductive reasoning together in a unique way. Can you speak to that?
Yes, that is what is called phenomenology. Phenomenology means what? It means that you're not trying to impose certain ideas onto matter. You're not, or onto the physical process. You don't have preconceived assumptions which you are bringing in. So that means that the excessive deduction is not going on. You're not just assuming things out of a hat. On the other hand, the inductive sciences right now, what they do is they keep collecting the physical data, but they do not have the organizing idea that can shed light on the whole system and bring coherence to it. So you're neither going towards the extreme of blindly collecting data, nor are you going to the extreme of pulling ad hoc ideas out of a hat. You're trying to go the middle ground where every fact, you're seeing it without assumption and allowing the fact to show the idea that it is carrying. So that's phenomenology. Yeah.
We've got another question here. Rudolf Steiner describes warmth without matter as the primordial condition.
Right.
How does warmth relate to linear and rotation motion as primordial conditions?
Right. So what is happening is when Steiner is speaking about warmth, he is talking about something that precedes linear and rotational and actually their interaction. Or if you are looking from the perspective of light, warmth can only be expressed as the interaction of linear and rotational motion. So even in reciprocal system, warmth turns out to be a kind of vibration. He calls it a linear vibration or something like that. I won't go into it now. But what happens is when something more primary gets expressed in a system that is at a different level, then that more primary phenomenon comes at the boundary of the polarity that we have just been discussing. So in other words, it does not discount warmth as another starting point. It only says where you reach when you start with light.
Well, you talked in your paper about how, for instance, Euclidean geometry describes a certain, the phenomenon of touch.
Yeah.
It seems to be related to this, while the phenomenon of sight is really a world of projective geometries.
Exactly. Yeah, that is actually the contribution of both Bruce and Nehru. They were the ones who identified that you not only need a reciprocal system in terms of speeds, but you also need a reciprocal geometry. And the pursuit of that idea actually led to incorporating projective geometry in the reciprocal system.
And that's RST2 that Bruce and Dr. Nehru developed.
Yeah.
Can you talk a little bit about, both of you are active with mainstream science groups and have been for decades. You have, Bruce, with the International Group for the Unification of Science, right? And
US, yeah.
Yeah, can you tell us how adoption of this theory is going in mainstream science?
Yeah. They hate us.
Very difficult. The fundamental stumbling block is what I addressed in the very beginning. that matter is being secondary and movement being primary, very hard pill to swallow for almost all of mainstream science. So that has not gone down too well, to be honest. Even though, when I was doing the PhD and dealing with concepts within conventional science, it became very clear that once you peel away the layers of assumptions, what is happening is very simply and straightforward manner explained by the reciprocal system. So it's not a problem of there being, contrary data or all these kind of things. The main problem is conceptual blocks. The conceptual block of keeping movement prior to matter is the block with respect to.
Well, they need blocks to move around. They will not accept just change.
Yes. By starting with bricks or Lego.
If you haven't got a brick, you can't
do anything. Yeah. So that's usually the attitude. So it doesn't matter. Electron, proton, even photon, you have a whole ton of ons, all of which is the very basis of conventional science.
Well, people are attached to stuff, right?
Yep.
Yeah, it makes people feel secure to have a lot of stuff.
Yeah.
We had another question come in that we don't have a lot of equations in Larson's books, and you spoke about that in your paper. Can you speak to how we can give more support for the theory by giving detailed mathematical equations? Well,
the equations, you see, the idea of what has been is, first people weave out the equation and then they try to fit it to the phenomena. And Larson takes the inverse approach. He doesn't impose equations on stuff. He derives the equations. So that is why you don't find a whole ton of equations in his books. But we have extended that work quite a bit. And many equations, for instance, the Schrodinger equation, which comes in quantum mechanics, can be derived straight from the reciprocal system. And there is a reason for everything now. You're not stuck with uncertainty principles. You're stuck with reciprocal principles. And you don't have to kind of give excuses when you bring in imaginary numbers. So in the reciprocal system, you have imaginary numbers coming out quite naturally. So the way to promote this or to take this forward is, just try to study study Larson's works, interact with us, and we'll try to take it forward.
Now, I want to ask both of you to imagine for a moment how not only science and technology might be different, but culture and our understanding of ourselves if the reciprocal system of theory were the mainstream theory of physical reality.
Yep. Bruce has done a lot with that.
I've extended the system well into metaphysics and spirituality. It all turned out to be a natural consequence of this theory. Everything we see or don't see is there. And it allows you to understand what is true with the universe versus what's been made up. I think that's probably the strongest thing the reciprocal system has. Even when physicists start these experiments and you see all these fancy papers, well, they're lying because that can't be. There is not a natural consequence of this system. Do you want to?
Yeah, and because it gives a very clear idea of what exists in the physical universe, and once you subtract that out, you get
beyond space and time.
Then you get beyond space and time, which is again one more excellent book by Larson, and that is kind of what actually leads over to anthroposophy. When you're looking at spiritual scientific concepts, they're just what Larson began and just far more elaborate. So yes, getting the physics right goes a long way in getting the metaphysics right.
Now you need the foundation before you go for the good stuff.
Yep.
That's really incredible because you've just laid the groundwork for a culture that rests on truth.
Yes.
It's hard to hide false in the reciprocal system because if it's not space to time, it's not motion, and it's not going to happen.
Yeah.
Well, you have an idea for another webinar, that we talked a little bit about, Gopi, something about time.
Yes, we actually did not enter into that subject at all in this presentation, because the reciprocity between space and time means that time's properties also turn out to be very different than what we conventionally assume. So hopefully...
Well, they turn out to be the same as space, so time has 3 dimensions.
Yeah. So that is the subject that we'd like to touch upon at another time.
Okay, we are going to look forward to that. I want to thank both of you, Bruce and Gopi, and everyone who has attended this webinar. Please look for a follow-up email with a link to the recording. We would like to have your feedback, audience, as we're developing future webinars on the subject of science and technology, and also subjects like psychology and social threefolding. So please send your comments to admin@cfae.us. We'd like to express our gratitude to Frank Dauenhauer and the Center for Anthroposophical Endeavors, the not-for-profit organization which makes these webinars possible. Please consider a gift of financial support at cfae.us. Thank you and good night.
Thank you.